Hey guys, in this lesson we would be learning how to deal with trigonometric ratios of special angles and the angles from 0 degrees to 360 degrees that have relationship with special angles. In the previous two lessons we learned what are special triangles. We know these are special triangles that help us find the trigonometric ratios for special angles. Also we learned the relationship between the related acute angle and the principal angle. We know if the angle lies in the first quadrant, then theta is equal to beta. If angle lies in the second quadrant, then theta is equal to 180 minus beta. We can solve for beta if we know theta by isolating beta. We know it from the third quadrant, theta is equal to 180 plus beta. Also we know if the angle lies in the fourth quadrant, theta is equal to 360 minus beta. We also learned from the unit circle that the trig ratio of an acute angle will be equal to the trig ratio of any angle greater than 90 degree with related acute angles same as the given acute angle. In this scenario, the difference that we would see in both the trigonometric ratios would be that of the signs of the ratio. It could be positive, it could be negative, and the sign is determined by what is called cast rule. And the cast rule is that if we are in the first quadrant, all the trigonometric ratios are positive. So you always write down C, A, S, T, where C means cos positive, A means all positive, S means sine positive, and T means tan positive. If we're in the first quadrant, then all the trigonometric ratios are positive. If we're in the second quadrant, then the sine trigonometric ratios are positive. When we say sine, even the reciprocal of sine is positive. That is, cosecant is also positive. If we are in the third quadrant, when I say if we are in the third quadrant, means if the angle lies in the third quadrant, then the tan ratios and the reciprocal of tan, that is cot, is positive. And if the angle is in the fourth quadrant, then cosine ratios and its reciprocal, that is secant ratio, is going to be positive. Now let's understand this with a simple example. When we say cosine 45 is a positive 1 over root 2, because this 45 degree angle lies in the first quadrant, that's why it is going to be a positive ratio, because in the first quadrant all the ratios are positive. Whereas if we say cosine 135, now if we want to find out the value of cosine 135, we know 135 because it lies in the second quadrant. Therefore the beta for 135, or the related acute angle for 135, is equal to 180 minus theta, which is 135, and that is equal to 45 degrees. So the statement says trigonometric ratio of an acute angle 1 over root 2 is the trigonometric ratio of an acute angle 45 degrees when it comes with cos is equal to the trigonometric ratio of any angle that is greater than 90 degrees. So this angle is greater than 90 degrees. So now we are trying to find out the trigonometric ratio cosine of 135 degrees with the related acute angle same as the acute angle. And we got to see that the related acute angle for 135 degrees is 45, and the acute angle 45 that we've got the ratio for is going to give the same ratio as cos 45. So that would give us 1 over root 2. Now in this scenario, the difference would lie in the signs of the ratio. So we know this sign is positive. What sign would come here? That's what the goal is. Now the sign is determined from cast rule. So we go back to the cast rule circle, also called the unit circle. We know this 135 degree angle lies in the second quadrant, and second quadrant is good for sine ratios being positive. We are looking for a cosine ratio. Therefore, in the second quadrant, the ratio is going to be negative. So we would use both of these conditions, condition number 1 and condition number 2, in order to determine the trigonometric ratio of an angle that is greater than 90 degrees. For all the angles that are less than 90 degree, or for all acute angles that lie on the special triangles, we would just be using the special triangles. But when it comes to angles greater than 90 degrees that have a relationship with the special angles, means their related acute angle comes from the special triangles, then we would use the special triangles, scenario number 1 and scenario number 2 altogether. Let's use all of these concepts together to do some problems in order to understand it better. Let's say we have to evaluate the trigonometric ratios for the following special angles. We notice that these angles are acute angles. That means they lie from 0 to 90 degrees. And also these angles are special angles. So in order to complete this question, we only have to use the special triangles. So we go to 45-45 triangle to find out the sine 45 ratio. We know sine is opposite over hypotenuse. So sine 45 is opposite over hypotenuse, that is 1 over root 2. Therefore, the answer that we get is 1 over root 2. If we are required to rationalize the answer, rationalizing means getting rid of a square root in the denominator. All we have to do is just multiply root 2 both with the numerator and denominator, and that would give us root 2 over 2, because any radical when multiplied by itself would give us a whole number. Next, we want to find out what is secant 60. We know this is also a special angle, and we know cosine is cos, so that is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. We go to 30-60 triangle. This is our 30-60 triangle. We are working with 60-degree angle, and we want to find out the secant ratio. Secant is hypotenuse over adjacent, so that is 2 over 1, and this would give us 2 as an answer. Next, we have to find out the trigonometric sine ratio for 30 degree. Again, we go to 30-60 triangle. Sine is opposite over hypotenuse. We know this is 30 degrees. Opposite for 30 degrees is 1. Hypotenuse is 2. So this is going to be 1 over 2. Therefore, we write down sine 30 as 1 over 2. Now we would go to 60-30 triangle again to find out what is tan 60. We know tan is ptoas, so tan is opposite. This is the opposite side and this is the adjacent side for 60 degrees. So it's root 3 over 1. We write down tan 60 as root 3 over 1 minus cosine 30. Back to 30-60 triangle. Cosine is adjacent over hypotenuse. For 30 degrees, adjacent is root 3, hypotenuse is 2. So cosine 30 is root 3 over 2. Now we've got all the ratios. All we have to do is just evaluate and find the final value. We know we have to use BEDMAS because this is multiplication, and then we have to subtract it. So when we multiply these two, we would be able to get root 3 over 2 minus root 3 over 2. And that would give us a 0. This is how we evaluate, or this is how we find the ratios of angles that are present on special triangles. You see, we need not use a calculator for all this. All we have to do is just use special triangles. Now let's say we have to evaluate trig ratios for angles greater than 90 degree that have relationship with special angles. Now what do we mean by this relationship with special angles? This means that we're talking about those angles greater than 90 degree that have related acute angle equal to special angles. Therefore, to do these type of questions, there are steps that we have to follow. The first step is we find the quadrant in which the angle lies. Next step is we find its related acute angle. Related acute angle means beta. If beta is a special angle, then we use special triangle to find its trig ratio. And after we are done that, we would use cast rule to find the sine of the ratio. Finally, we would write down our final answer. Going back to the question, let's apply the steps. We find the quadrant in which the angle lies. Always remember, if the angle is from 0 to 90, it's the first quadrant. If it's from 90 to 180, it's second quadrant. If it's 180 to 270, it's third quadrant. And if it's 270 to 360, it's fourth quadrant. Since the angle we are working with is 120 degree and that lies in the second quadrant, so we got to know this is quadrant 2. First step is done. Next, we find its related acute angle. Now we'll check the relationship formula between beta and theta for quadrant number 2. Quadrant number 2, theta is 180 minus beta, but we are looking for beta value. We know theta that we are given is 120 degrees. Therefore, beta that we would get is, we just have to isolate beta. So we'll move beta here and we'll move 120 here. We get 180 minus 120, and that is equal to 60 degrees. And we notice that this beta is a special angle. So they said if beta is a special angle, use special triangle to find its trig ratio. What trig ratio are we looking for? Same as what we want to find out for the question. So we are looking for sine 60. Let's find out what is sine 60 from the special triangles. And we can see here sine 60 is opposite over hypotenuse. So that would be equal to root 3 over 2. Now we know from this scenario that the ratio sine 60 would be equal to the ratio sine 120, the same way as the ratio cos 45 is equal to ratio cos 135, because the related acute angle for 135 is 45. So we can write down sine 120 degree is equal to sine 60 degree. The only difference is the cast rule. So we'll go back to the cast rule circle in order to find out what sign the sine ratio is going to have in second quadrant, as this angle lies in second quadrant. So we are working everything for the second quadrant, and we notice here that the second quadrant is positive for sine ratios. Since we are also looking for sine ratio, the result is going to be positive. So final answer is sine 120 degrees is a positive root 3 over 2. Once you know all these steps thoroughly, you would not take so much time to solve a problem. Similarly, we can do another question for the sake of practice. Let's say we want to find out cot 240 degrees. So the first step is to find out what quadrant would it lie in. We are working with 240 degrees, and 240 degrees angle lie between 180 and 270 degree. Therefore, this lies in the third quadrant. So this is quadrant 3. That's the first step. Second step is we find out the related acute angle. For third quadrant, theta is equal to 180 plus beta. Therefore, beta will be equal to theta minus 180. We have theta as 240. 240 minus 180 is equal to 60 degrees. So we got the beta value as 60. Third step is we find the cot ratio for 60 degrees, because the cot ratio for 60 and the cot ratio for 240 is going to be same. And this we will be finding using special triangles. We know cot is adjacent over opposite, because tan is opposite over adjacent. For 60 degrees, adjacent is 1 and opposite is root 3. Therefore, we would write down 1 over root 3. The same will be the ratio for cot 240 degrees. That is 1 over root 3. Sine is decided by the cast rule. You know, cast rule is C-A-S-T. We are in the third quadrant, that is this quadrant, and third quadrant is positive for tan as well as its reciprocal. Cot is a reciprocal of tan. Therefore, this is a positive ratio. Hence, our final answer is cot 240 degrees is equal to a positive 1 over root 3. This is how we find the trigonometric ratios for angles that lie on the special triangle, as well as for the angles that are greater than 90 degrees and have connection to the special angles. The examples that we covered asked us to write down the trigonometric ratios. What if we're given a vice versa question? That means, let's see, if you're given the trig ratio of special angles and we're asked to determine the value of theta, where theta lies in between 0 and 360 degrees, then how do we do such kind of questions? Let's take the first example. We're given cosine theta is equal to root 3 over 2. We are given these two triangles, and we know root 3 and 2 can be found out on 30-60 triangle. And we also know cosine theta is adjacent over hypotenuse. So for which angle the adjacent is root 3? Root 3 is here, and for which angle it is going to be adjacent is 30 degrees. Therefore, from here we get to know that the theta is going to be equal to 30 degrees. Now, this is not just the final answer, because we are given another thing here, is that we have to determine the value of theta if theta lies in between 0 to 360 degrees. We have just found out the answer for acute angle, and we know trigonometric ratios are repeated 4 times when we go from 0 degrees to 360 degrees. 2 times they're repeated with a positive sign, and 2 times they're repeated with a negative sign. Now we would see here cos theta is given to us with a positive sign. No sign means it's positive. So we would first find out, using the cast rule, where is cos ratio positive. We know this is all positive, so definitely this is where the cos ratio is going to be positive. And this is cos positive, so here also cos ratio is going to be positive. So we would see cos theta is equal to positive root 3 over 2 in quadrant 1 and quadrant 4. By using special triangle, we got the answer for quadrant 1. Because they want all the answers that lie from 0 degrees to 360 degrees, we have to find out the second answer that would have the same positive root 3 over 2 ratio. And from the cast rule, we got to find out that the second answer would lie in quadrant 4. Always remember, the answer from the first quadrant, which is 30 degrees, would behave as a related acute angle for the rest of the quadrants. Therefore, for quadrant 4, related acute angle is 30 degrees. We need to find out what is the principal angle for quadrant 4. And whenever we have to find out the principal angle from related acute angle or related acute angle from principal angle, then we use these rules. Because we are looking for the fourth quadrant, therefore we would use the rule for fourth quadrant, and that is theta is equal to 360 minus beta. Hence, here in order to find out theta, we would use theta is equal to 360 minus beta. Therefore, theta is equal to 360 minus beta value is going to be 30 degrees, which is equal to 330 degrees. Now we've got two answers. Cos 30 would give us a positive root 3 over 2, as well as cos 330 will also give us a positive root 3 over 2. Therefore, the theta angles are 30 degrees and 330 degrees. Let's take up another question for practice. We're given cosecant theta is negative root 2, and we're supposed to find out the value of theta. We're given the two special triangles. If we're not given the special triangles, then we have to draw it ourselves because we have to memorize the special triangles. We know cosecant theta is reciprocal of sine theta, and sine theta is equal to opposite over hypotenuse. Therefore, cosecant theta will be equal to hypotenuse over opposite. Now, out of these two triangles, which triangle is applicable to this question is we would see where is square root 2 present, and that is present in the second triangle, so that's why we would use the 45-45 triangle. Now, we are looking for cosecant theta that is equal to hypotenuse over opposite. So, we are looking for what angle hypotenuse is, root 2, and that is 45 degree angle. So from here we get to know that theta is equal to 45 degrees. Now since we're supposed to find out theta that lies in between 0 and 360 degrees, the next step that we would do is use cast rule, and we would look where is sine negative, because cosecant is reciprocal of sine. So we would see where is sine negative in this unit circle. We know this is all positive and this is sine positive. Therefore, sine is going to be negative in third and the fourth quadrant because our ratio is a negative ratio for cosecant. So the answer also comes from third and fourth quadrant. When we use the special triangle, we got an answer that is an acute angle, and that angle lies in the first quadrant. Whereas first quadrant is not our answer because we are not looking for a positive ratio. We're looking for a negative ratio. So we would use this theta as beta because the angle from the first quadrant is going to behave as beta for the rest of the quadrants. So beta is 45, and we would use this beta 45 to find out the quadrant 3 theta, that is 180 degrees plus beta. We would do 180 plus 45, that is equal to 225 degrees. And we would use the same beta for finding the theta of fourth quadrant. Fourth quadrant rule is 360 minus beta. We have 360 degrees minus 45 degrees, which is equal to 315 degrees. Therefore, the final answer is if cosecant theta is negative root 2, theta will be 225 and 315 degrees. And in this case, the role of your special triangles was that to find out the value of beta, because beta is the value that will help us find out theta from any of the other quadrants. And this is how we get the angle when we are given a trigonometric ratio. Trigonometric ratio can be given with a positive sign or with a negative sign. And the steps that we have to follow are all these if the related acute angle is a special angle.